So today we get to move on to our next little topic in our appendix. So we're going to move on to A.2.1, and it has to do with sequences. So we need to go through and kind of define what a sequence is, and then we're going to mess around with some and see if we can figure out how we can get from one number to the next. Yes, sir.
Okay.
Pardon me? Yes. So a sequence is like a set of numbers, and if we go back to like the beginning of the chapter when we were talking about the rabbits and that rabbit population, and if we were actually to graph like how many rabbits like throughout the months were being produced, it's called a discrete graph. Or if you're thinking of the number of, if we even go back one more chapter when we were talking about like how many buses you need, those were called discrete functions, because when we graph them, we wouldn't graph the line being continuous. We wouldn't connect all of the dots, because you can't have a half a bus, just like you can't have a half a rabbit, right? So when it comes to how do you show that data, we use sequences. So sequences are used for like discrete data. So discrete is like one here, one there, one down the road type of thing. So a sequence is just an ordered list of numbers. And we're going to put on there that this is discrete. So, for example, we could have 2, that looks like a Z. We could have 2, 6, 18, 54. And then a lot of times we throw these 3 little dots at the end. Anybody want to guess what those 3 little dots on the end are for? Yeah, to be continued. I like that one. Yep, it's going to keep going, right? So it's kind of like a never-ending sequence of numbers. It's going to continue and continue. Yep. Couple different things on how, when it comes to discrete number or any sequence, we look at how, and this is part of what today's lesson, we're looking to see how do we get from one number to the next. And sometimes they refer to that as a growth pattern. Technically, getting from one number to the next is the same thing as like finding the slope, or we also call it like the common difference. How do you get from this number to this number? There's 2 types of sequences, and we'll get to those. One is when you're adding a number to get from one to the next, and the other one is if you're multiplying to get from one number to the next. Sound good? So when it comes to these, it really kind of just takes a little bit of practice, kind of to, the more you do it, you kind of start picking up on the pattern a little bit more. Because we need to figure out how do we get from 2 to 6, and from 6 to 18, and from 18 to 54. Yeah. So like usually like the easiest would be like adding or subtracting. So it's kind of like a trial and error. If we wanted to go like with adding and subtracting, to get from 2 to 6 you would add 4, right? But you got to keep it consistent. So if I added 4 to get to here, I'd have to add 4 to get to here. And if I add 4 to 10, am I going to get to 18? No. So that's kind of like how you then say, okay, maybe it's not addition. Maybe it's multiplication, right? So what would we multiply 2 by to get to 6?
3.
Multiply it by 3, right? If we go from 6 to 18, how are we going to get there? 3. 18 to 54? 3, right? And then as we keep going, if we keep multiplying by 3, then we can expand our sequence. So that that growth pattern would be by multiplying by 3, or sometimes they'll refer to it as the slope. It would be by 3, or that common difference is 3. The other little word we like to throw around are terms. So on the board in our sequence, how many terms do you think there are shown right now? 4, yep. So this is a term, this one's a term, this one's a term, and that one's a term, right? And then, so if we wanted to know the 4th term in our sequence, what's the 4th term in our sequence? 54? Yep. Could you find, I'm going to squeeze this up a little bit. Could you find the, I don't know, pick a number.
5.
Let's pick a number between 6 and 10.
6.
6. I like that
Shut
one.
up.
We'll do a little you try / you do. Find, what did you say, the 6th?
6, yep.
Find the 6th term. So first person with the answer to the 6th term gets an attaboy.
864.
486.
I just took it.
We going with 486?
What do we get?
You get an attaboy. After 5 attaboys, you get a way to go. Aren't I? Oh, this was hilarious. You got to hear this. During pre-calc today, we were talking, part of the problem we had to, distribute, like inside the parentheses. And you know how I'm always like, in Fitch's class, if we're sharing, we're caring type of thing. And then it came up, it's like, we're sharing and caring.
That was embarrassing.
Charles, you win.
I thought it was hilarious.
Karen is a bad thing.
No.
I love hearing Jordan's voice in the back.
Sorry, I'm
All
going
right.
to Karen run away.
Karen.
So let's look at some sequences. All right. So let's see if we can figure out what's going on in a ton of different, we got, I don't know, a whole chunk of them maybe. We'll see how we do. All right. So let's say we had the sequence, I'm just going to name them, this is A. Let's say we had -4, -1, 2, 5, and it's going to keep going. So let's see if we can figure out how do we go from one term to the next. What do you guys think?
Oh, wow.
What are we doing?
Adding 3.
Adding 3?
I don't have to treat it.
You planting a forest? Adding tree? Yep. Everybody good with adding 3 on that one? All right, ready for another one? Let's say we had 9, 7, 5, 3. And that sequence is going to keep continuing.
Or you're going to subtract 2.
She said that sequences are going to be on
Mhm. So we're adding what? -2. Or we could say that we're
So either one would be correct.
subtracting 2. Yeah, like you're looking for the number, like, so yes. So you would actually be looking for like -2.
Okay.
Yeah. Yep. But if you think of if you were to put it in words and you were to write subtracting 2, that's fine. But then we're ultimately the end, we're gonna actually come up with the equation for it. As long as you know subtracting is -2,
Okay.
you're good. Yep. All right, let's try another one. Ready to get fancier? What about 2, 3.5, 5, 6.5?
Adding 1.5 to every single
Ooh. Adding, what was it, 1.5?
one. Yeah.
guys ready?
Yes, ma'am.
What if I gave you guys 3, 6, 12, 24?
Yeah, they're all. Oh my gosh, you multiply by 2. What does that get?
Multiply by 2.
Yeah, their county is also short.
All right, let's keep going then. I think you guys are picking up on what I'm laying down. What about 48, 8, 24, and 12?
Multiply by half.
Multiply by half.
Negative or positive?
No.
You would do
No, be your
negative
by
half.
half.
Okay. All right. I gotta figure out how to turn my notifications off. I don't have a phone in here, so for the school to get a hold of me, I gotta have my phone on. I turn my ringer down, but then my notifications come up all loud. I don't know.
Is your, do you have a button, do you have an iPhone?
Yeah.
Do you have the notification button that's,
Oh, there we go.
yeah, do not
That disturb. Yes. Yes.
Yeah, that's the. It looks like
But will it still? Because like they'll either call me or text me. Will the calls and texts still come through?
Yeah, but it just won't make a sound.
Gotcha. Okay.
It'll come in through silent mode. It's silent mode.
Nice. Right. Right. So like you guys said, we're gonna multiply by a half, right? Nice. All right. We got to go one more, right? What if we went, let's say, 27, -9, 3, -1?
Times by -3.
What are we doing?
Multiplying by negative.
Multiplying. Whoops. Can't. By -3?
Indeed.
Yeah,
27.
yeah, it's negative 9 divided by -3.
So if I'm,
It is positive. Add humongous brain.
Your brain is not humongous.
so then to go from here to here, I have to do 27 times -3, and that gets me -9.
No, you can divide.
Uh,
That's your brain is.
yeah. So if we just think of multiplication, though, it would be multiplying by
Negative something.
negative something. Yeah. -1/3. There you go. Good job. Awesome. All right. So these two little guys, well, these two sets, all get to get put into a category. I kind of ran out a little bit of room. We're gonna take that away for now. Whoop, 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 whoop. All three of these, because you are adding a number, these ones are all called arithmetic sequences. So think of arithmetic. See how that kind of, is that blue too bold for you guys? Yeah, let's sit up there. Yep. And these three, where you are multiplying them, these ones are referred to as geometric sequences. Isn't that just neat? Yep. So I could even give you guys a vocabulary quiz, right? Explain to me the difference between arithmetic and geometric sequences.
Go ahead and only go up 2%. I got an 8 out of 9.
Oh, it's okay. It's okay. All right. So for today, on your guys' lesson, they have you It says find the slope of the line you would get if you graphed each sequence listed. So if we're looking for slope, we're looking for that slope, that common difference, that common factor, that part of it, right? 46 has you coming, find the line that passes through 2 points, and it tells you to find the slope and then find the equation of the line. So put it like into slope-intercept form. 47 has you looking at some chocolate chip muffins for the food fair at the school. And we're gonna see how many ounces of chocolate chips we need. 48 has to do with the area of a square. So they give you the area of the square and they want you to make a diagram on what the lengths of those sides are gonna be. And do we know how to find the area of a square? You do? Awesome. Sweet. And then 49 has you referring back to sequences. And there's a list on the page that kind of goes along with these ones. I kind of took them out of order so I could group them. But you're going to refer back to that page that has those sequences, and we're going to talk about some of those factors. And then number 50, they have you looking at a table and seeing if you can kind of figure out what's going on with the table and how they're getting from one number to the next. Sound like a plan for today? Awesome. Yes, sir.
I have to take this.
Yes, you do. Yep. We'll talk here in a minute. Yep. All right. If you guys are good, I'm going to stop the recording.